For this problem, it says find the volume of the solid that lies both within the cylinder x squared plus y squared equals 1 and the sphere x squared plus y squared plus z squared equals 4. Okay, so sorry about that mess up there. But we should draw this region out, if it helps you. Okay. So, to draw our cylinder, we can see that it does not depend on z, so it stretches along the z-axis. So it's of radius 1. So as you can see, it's radius 1. So it looks something like this. Stretch it down. Something like that. Okay. And then the sphere is of radius 2. So it'll look something like this. Okay. So we want to find this, the volume of this region inside. Okay. So how do we do that? Obviously we need a triple integral for this one. But should we use regular xyz? Should we use cylindrical coordinates? Should we use spherical coordinates? This one, you might not be able to tell right off the bat, so let us analyze. We see that the z is bounded by the sphere, not by the cylinder. So right here is the upper bound of z, right here is the lower bound of z. Okay? And then x and y is just this, that is bounded by the cylinder. Okay? So this one, it will be most useful to use cylindrical coordinates, especially to get our x and y. It'll be really easy. Not so much for spherical because it's not really bounded by a sphere as much. Okay. So if you write this as z squared equals 2, 4 minus x squared minus y squared is the same as 4 minus r squared. Okay. So z is equal to plus or minus square root of 4 minus r squared. And those are your upper bound and lower bounds of z. So one, boom. Okay. So this is from minus 4 minus r squared, square root of 4 minus r squared. Okay. And then for, because we're doing it in cylindrical, we need r and theta. So r is just bounded by the cylinder, because we took care of the z already. So it's bounded by cylinder, so it's radius of 1, so 0 to 1. And then theta, we go around the whole cylinder, so 0 to 2 pi. Okay. And then we don't have a function explicitly, so it becomes r, dz, dr, d theta. Remember, you need an extra factor of r. Okay. So how do we integrate this? If we do with respect to z first, we'll end up with 2r squared root of 4 minus r squared dr d theta. There's no z, so we add a z when we integrate. So, and then we plug in this minus that. So you get 2 of the square root, and then we have the r still. Okay. And this we can split up into 2 integrals. So I factor out the 2 in the front, this is constant 2, so d theta, integral from 0 to 1, so times integral 0 to 1 of r 4 minus r squared. Actually, we could put the 2 over here, a little bit easier. dr. Okay. So for this one, it's obviously just 2 pi. For this one, we can make a little substitution. U equals to 4 minus r squared. Du be minus 2r dr. Okay, so this is times negative integral. So we need to change the bounds. So this is from 4 to 3. Is that right? Plug in 0, we get 4. Plug in 1, we get 3. Yes. And then this is just square root of u du. Okay. Now, we can always change the bounds to 2 pi. Integral from 3 to 4 a square root of u du, which is just the power rule. So this is 2/3 u to 3 halves from 3 to 4. Okay. So now this is equal to 2 pi times 2/3. So this is square root of 4 cubed minus square root of 3 cubed. Okay. So this is just 4 pi over 3 times, this is 8 minus square root of 3 cubed. Okay, so that should be your answer.